Unit 9, Part 1, Dilations of 2D and 3D Figures, Day 1, April 22nd and April 21st. Make sure the notes pages on 2 to 5 are complete, the pizzazz on page 6, the homework on page 7, and the practice pages on pages 8, 9, and 10. So a dilation is a transformation that produces an image that is the same shape as the original but is a different size. The center of a dilation is a fixed point in the plane about which all the points are enlarged or reduced. A dilation that creates a larger or a bigger image is called an enlargement. Or an expansion. And a dilation that creates a smaller image is called a reduction or a contraction. Please note that a dilation is not a rigid transformation. Rigid transformations preserve the length. Dilations do not. A description of a dilation always includes the scale factor or a ratio, or the scale factor is a ratio, I should say, and it also includes the center of dilation. The center of dilation is always going to be a fixed point in the coordinate plane, and if the scale factor is greater than 1, the image is an expansion, which makes sense because numbers multiplied by numbers larger than 1 get bigger. And if the scale factor is between 0 and 1, the image is a reduction, which means the image gets smaller. Which again makes sense because when you multiply a number by something between 0 and 1, like a fraction, you're going to get a smaller number. And if the scale factor is 1, then the figure and the image are the exact same size, meaning they are congruent. So if you look at the picture in your packet, we have the center of dilation, and as it gets bigger, as it goes out, we're going to make sure we keep that center point as a description. And then this box here just reinforces. The scale factor is often referenced with the variable k. I don't know why. That's just what they picked. So looking at these examples, you'll notice that the original figure here, A, B, C, has the points 0, 2, 2, -1, and -2, -2. And then its dilation, notice the points now have this little apostrophe next to them. That indicates that it is the new image. The original is called a pre-image, and we'll talk more about that later. But then the scale factor of 2, the new points are 0, 4, 4, -2, -4, -4. On the flip side of that, if we have the inverse of 2, which is 1/2, and have a scale factor of 1/2, now our new points, you'll notice that the shape is smaller. We've gone from -2, 4 to -1, 2. Basically what we're doing is we're taking our points, for example, let's take point C from this one, of -2, 2, or -2, -2. And a scale factor of 2, we're just multiplying both of these times 2, giving us -4, -4. And notice that is the point for the new C. Likewise, multiplying these by 1/2, if we take point D of -4, -2, and if we divide each of those by 2, we end up at -2, -1, which is the coordinates for D prime. So let's do one. Let's look at this big one down here. So we have the dilated, we're going to graph the dilated image of JKL using a scale factor of 2. So we've got the points JKL. First we're going to put their coordinates. J is 2, 1, 2, 3, 2, 4. K is 1, 1. And L is 4, 0. And with a scale factor of 2, I'm just going to double each of those. So now I'm at 4, 8, 2, 2, and 8, 0. Now I'm going to plot those. I'm going to come over 4 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to come over 2, up 2. Oh, I've got to label that J prime. A little asterisk, the apostrophe means prime, so that's what those points are. Oops, I put J instead of K. K prime, and then L is over 8, up 0. And then we connect those with our handy dandy ruler. And that's it. That's all you do. I'm going to let you guys try this one on page 4. Move that up a little bit, just a little bit easier to see. Pause the video while you do page 4. Come back, we're going to do page 3 because it's got a scale factor of 1/2. Did you pause and do page 4? Pause and do page 4. Okay, now let's do page 5. So we're going to graph the points for M is 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 6, 0. O is 3, 1, 2, 3, 4, 5, 6, 3, -6. P is 1, 2, 3, -3, 0. Cut all of those in half, and now I have 3 over 2, 9 over 2, and then I have 3, 0, and I have 3 over 2, -2, and then -3 over 2, 0. So I'm going to plot these. Well, 3 over 2 is 1.5. So I'm going to come over 1.5 and come up 9 halves or 4.5. 1, 2, 3, 4.5. And that is my M prime. And then 3, 0 for N prime. And then 1.5, 2 for O prime. 1.5, 0 for P prime. And again, connecting those with my ruler. And there you go. That shape is the same shape as the other one, just smaller. Did I do something wrong? Because that doesn't look right. Nope, I got them. So, all right, that's how you do that part. All right, ladies and gentlemen, this is your pizzazz page. That needs to be done. I'm going to zoom out so you guys can see more of that. This is your homework, but again, if you get it done in class, that's totally fine too. Page 8 is some additional practice. It says day 2 at the top. That's day 1. We had 4 days in this unit and then we had to take one out. Do page 9. Do page 10. And I believe, yes, your homework stops on page, actually on page 12. 10. No, it does not. It stops on page 10. Yep. So do your homework through page 10 and I will be checking that next class.